So we've got theorems about zeros of polynomial functions. Basically, what this is saying is that we're going to find a polynomial with specified zeros in 8.4. We're going to find the rational zeros and the other zeros. Remember that there's zeros that are just square roots and they don't come out even. There's also imaginary zeros sometimes that we don't see on our graph. So we're going to be able to find, the goal is that we can find all of the roots. So they have this factor theorem. To me, the theorems are like the most difficult, trying to remember what they mean and when I can use them. So let's just talk about this real quick. For a polynomial f of x, if f of c is equal to 0. Well, already I know what this means. So here's an example. If I plug in, let's say I plug in a 2 and the answer is 0. So I've got this big long equation and I plug in 2 and the answer is 0. We've been talking about in the rest of chapter 8 what that means. What does that mean about the number 2? You can plug in 2 into the equation and you get 0. It means it's a 0. It means it's an x-intercept, right? So hopefully you can remember that if you plug in 2 and you get an answer of 0, then that means 2 is a 0. It's also, so the 0.20 would be an x-intercept. It's where it crosses the x-axis. We know that from just that statement. So so they're saying here that if you have whatever number and you plug it in and you get 0, then it's a 0. Okay. And we also know that x minus c is a factor of f of x. So we did all that dividing the last class. And so what we know is that if you typed in your graphing calculator the function in the quad program, right, and you got that your x-intercepts or your answers, and one of them is 2, then what we just got through saying is that you could write that as one of the factors would be x minus 2. If the 0 is 2, then the factor is x minus 2. That's all that says. We already know these things, right? So this is saying if x minus c is a factor, then c is a 0. So here's an example of that. If x minus 3 is a factor, then what would be a 0? 3 is a 0 because it's the opposite, right? If 4, so I'm saying if 4 is c, if 4 is a 0, then x minus 4 is a factor. They just work interchangeably. That's all that theorem is saying. So you need to understand how those things kind of go together. Okay. So every polynomial function of degree n with n greater than or equal to 1 has at least one 0 in the set of complex numbers. So basically what we're saying is if you've got an equation and it has at least an x to the first power, you're at least going to have one 0. Every polynomial function of degree n with n greater than or equal to 1 can be factored into linear factors. We've been doing this since the beginning of class. We've been saying if you have a polynomial, you can factor it. That's what we just got through doing a lot in the warm-up, okay? So example 1 says find a polynomial function of degree 3 that has these zeros. They're saying one of the zeros is 1. I'm just going to talk about that one real quick. We've got one of the zeros is 3i, and the other 0 is negative 3i, and a sub n is 1. So if we go up here and look at this formula that they're asking us to write, f of x is equal to, what's the first thing they have? A sub n. They told us what a sub n is. What is it? 1. So we can put that down. It's not really going to change anything, but that's why I'm putting the 1 there, because the first thing in the formula is a 1. Then I'm going to do x minus c sub 1. Okay, that's this 1. The next thing I would do is x minus whatever this is. So if it's 3i. The next thing I'm going to, because I'm continuing this pattern and I'm subtracting off all of these. So x minus this one, which most of you already knew if it was a negative 3i, this one's going to be what? Should have been a positive 3i when you wrote it. So we don't really, when we write the final one, we don't really need, I'm sorry, that was still minus. We don't really need that one there. Multiplying by one just keeps the thing the same. Okay. Unfortunately, when you're typing in your answer, they're not going to let this be it. They're going to say, finish multiplying it out. Find the reduced answer, I guess. So whenever I'm about to find, does everybody understand this part at least? Okay. Whenever I'm about to find the reduced answer, what I want to do is if I've got one of these situations where I've got a minus and a plus, that's the exact same thing. That's the first thing. I want to multiply these two together first. I'm going to kind of ignore this x minus 1 right now, and I'm going to do FOIL on these two. Because if I can do that, this minus and this plus is a difference of squares. Something's going to cancel out of that. So just side note real quick, we talked about this in class on Tuesday or on Monday. If I have x squared minus 9, then that is the difference of squares because they're perfect squares. This would be x minus 3 times x plus 3. Y'all remember that? That's what this situation is. It's just backwards. We've got one that's minus and one that's plus, but they're the opposite. So it's going to, a lot of things are going to collapse out when we start multiplying these two together because they have the exact same terms. One is just negative and one's positive. They are the difference of squares. So x times x gets me x squared. X times positive 3i is positive 3xi or ix. It doesn't matter which way you write it. I'm going to move down to the bottom. Negative 3i times x is going to be negative 3xi. Negative 3 times positive 3i, or negative 3i times positive 3i. That's going to be negative 9i squared. Now keep in mind, I still have this x minus 1 that I haven't dealt with. I'll worry about it in a minute. Is there anything I can do to make this smaller? Yeah, I've got an x squared. That's not going to go away. But I've got a positive 3xi and a negative 3xi. That's just 0. This whole thing right here is negative 9 times, what is I squared? Negative 1. So negative 9 times negative 1 is, okay, so that helps me kind of reduce that down. So now I can do FOIL and be done with this. So x times x squared is x to the third. X times 9, 9x, that's right. Negative 1 times x squared. And negative 1 times 9 is negative 9. The last thing you might want to do is kind of put these in order, but I don't think you have to. Just with the highest power exponent on the x, because that's the way you're normally going to see it, but both of those answers are correct, right? So I'm done with this. This said this had 3 zeros, and so that means it's supposed to have 3 x-intercepts. Here's the graph of it right here. And there's the answer right there too that we just found. But why is there only one x-intercept, that one on this graph? When it says it has 3 zeros. They're imaginary, right? 3i is one of the zeros and the other i is negative 3i. And so in this case, imaginary numbers don't exist on a two-dimensional graph. So that's why you're not seeing those other ones. Okay. So everybody good with that one? Okay. Example 2, find a polynomial function of degree 5. So what does degree 5 mean? That means that it's possible for me to have an x to the 5th. It's possible for me to have 5 roots on this one because it has a degree of 5. So they're telling me some information that we talked about earlier in chapter 8. They're telling me that -1 is a 0 and it has a multiplicity of 3. So if -1 is a 0, when I write the factor, it's not going to be x minus 1, it's going to be x plus 1, because you're going to do the opposite of whatever's there. The multiplicity of 3 means I'm going to do what? I'm going to put a 3 up there. That's absolutely right. This one says 4 as a 0 with multiplicity of 1. So what's x what? To the first power. When we don't need to put the first power there, we know that's understood, but I'm just trying to make sure I'm explaining why that's a multiplicity of 1. And 0 as a 0 of multiplicity 1. That one can be tricky for people, but if 0 is a 0, then it kind of means x minus 0. And you wouldn't write that. You would just write x. Okay? But that's what it means. X minus 0 to the first power, because it's a multiplicity of 1. And so it just is x. And they said let a sub n equal 1. So f of x is equal to 1. That's our a sub n. X plus 1 to the third. X minus 4 to the first. And then we've got an x. And usually you would, if we were going to like write this a little bit, you would usually see the x in the front, and they wouldn't even put the 1. Okay, but those are the same things. So when you look at this graph over here, if something has a multiplicity of 3, it's supposed to cross over the x-axis if it's odd. Remember that? And all of these are supposed to cross over the x-axis because they're all odd. If the multiplicity is even, do y'all remember what it's supposed to do? Bounce off the x-axis, right? But what's interesting to me here is when you look at this graph, it kind of looks like it bounces right there. Okay, but this is a really small graph, and so if we kind of blow this up, we know that we have a 0 at 0 because they told us so, and we have a 0 at -1. They told us so right here. And that's kind of the points that it looks like it bounces off. So probably what's happening is it's going just a little bit over it. And we're so close up to it that you can't see it there, right? But it's not actually bouncing off. You look really close, you can kind of tell it goes a little bit over it. Okay, so that's kind of just review over 8.1 and 8.2. So now it's possible that you might have to multiply that out, but usually the computer's not going to make you multiply one out that has an x to the 5th. So I'm not going to torture you with that. When we talked about the quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. If we had to come up with an answer for that, sometimes we would come up with crazy answers like 2 plus or minus I square root of 2, right? And we would know it had 2 answers because there was a plus or minus. Sometimes we might come up with, this is just example answers, we might just come up with plus or minus 5 square root of 2 because we had a 0 in the front. The -b ended up being a 0 and canceling out. So when you see a term that has an I in it, the only way you can get that I is if you had a plus or minus. So if they tell you that 2 plus 7i is a 0, then that means there is also a 0 at 2 minus 7i. Okay, if you have an I in as one of your zeros, then there has to also be one that's negative. What you do is make sure that you leave the term in the front alone. So I didn't change the sign of the 2. I just changed the sign of whatever was in front of the I part of it. Okay, so on this one, I'm going to leave the -5 alone. But if -4i was a root, -5 minus 4i is a 0, then that means -5 plus 4i is also a 0. On this one, we don't have a number in front, we could rewrite this as 0 minus 3i. If you don't have a number in front of the I term, you don't have to put it. It's just the other one would be a positive 3i, a negative 3i and a positive 3i. That would be one of those cases where the number in the front is 0. It just went away, right? So if you have an I term, you're going to leave whatever numbers in the front alone, but the I is going to be the opposite. Both of those can be roots or zeros. Okay, same thing for square roots. So if you ended up getting an answer on your graphing calculator of 2 minus 3 square root of 2, right? The only reason the calculator pulls up the square root of 2 is if there's two options. One of the options is 2 plus 3 square root of 2, and the other option is 2 minus 3 square root of 2. Yeah. So those are the two cases. If you have an I, you're going to have plus or minus, and if you have a square root, you're going to have a plus or minus. The number in the front stays the same. That part doesn't change. That's this number. But if I have a plus 5 square root of 2, I'm going to have a minus 5 square root of 2. This one right here doesn't have a number in the front. This would be, if I were to write this out, it would be 0 plus 3 square root of 2. Because whatever that number in the front was, just was 0. It went away. So I would also have a minus 3 square root of 2. Gonna leave 6 alone. And if you've got minus 7 square root of 5, you're going to have a plus 7 square root of 5 as one of the zeros. Okay. So, example 3. Suppose that a polynomial function of degree 4. So that means that we can have an x to the 4th. It's possible to have 4 zeros with rational coefficients, and it's telling us that 2 of our zeros are negative 2 plus the square root of 5, and another 0 is negative 2i. So based on what we know, if negative 2 plus the square root of 5 is a 0, what else is a 0? If negative 2i is a 0, then that means positive 2i is also a 0. Anybody confused by that? So that has to be it. I can't have any more zeros than that. There's 4, and it's degree 4, so that's it. So find the other zeros. We took care of that. The other zeros are negative 2 minus the square root of 5 and 2i. Then find the polynomial. Okay, so if I told you the zeros are 3 and 5, let's go back and make a really easy one. If I say the zeros are 3 and 5, you're going to tell me that the polynomial to get started on this, you would say, oh, if the 0 is 3, then I would have an x minus 3. And if the other 0 is 5, that would be x minus 5. And you would multiply that out to reduce it, and you'd be done, right? This is the exact same thing. We just have ugly numbers to work with, not 3 and 5, right? So I've got 4 of these things. I've got 4 zeros. Here they are. So when I'm writing these out, we know that every single time we are supposed to subtract. So if our 0 is 3, we would want to say x minus 3. So we've got this, except for we have 4 of them. One of our zeros is negative 2 plus the square root of 5. I'm going to make this bigger. So x minus negative 2 plus the square root of 5. X minus negative 2 minus the square root of 5. X minus negative 2i. And x minus positive 2i. So it's possible that if I didn't have to simplify this, that could just be the answer. Okay. but I do have to simplify it. So here we go. We have X. This negative has to go with both of these things. So when I distribute that, a negative -2 is going to turn into +2. A negative, and then negative times a positive square root of 5 would be square root of 5, negative square root of 5. Is everybody okay with that part? Yeah. Okay. I'm going to do the same thing with this term. Write down my X. This negative gets distributed to both of these things. So negative -2, +2. Negative square root of 5, positive square root of 5. Everybody's okay with that part? This part, X minus a -2i would just be X plus 2i. And then X minus 2i, well, that's just X minus 2i. Okay. So say again, sorry. Okay. So I will be openly honest about some of this stuff. Watch me do this, because sometimes I do get mixed up in the signs while you're like, you're the teacher. But when you're looking at it sometimes up close, you do the same thing sometimes. But yeah, holler at me if I get something mixed up. So when we're doing this, we're trying to multiply everything by everything. Okay, so this second part right here is really easy to come up with. So I'm going to let's just get this out of the way. This one's easy. Let's do the back half first. So we can just FOIL this part out. X times X is X squared. X times -2i is -2xi or -2ix. It doesn't matter which way you say that. And then 2i times x would be +2xi or ix. And then you're going to do 2 times -2. That's going to be -4. And I times I is going to be I squared. So this term and this term, they're exactly the same. One's positive and one's negative. That kind of just goes away. I've got x squared. What about this? This is really -4 and I squared. So times -1. So +4. So I'm going to keep that in my problem, but I'm going to go start working over here, because that part was the easy part, because this one is multiplying 3 different things times 3 different things. So I'm going to start with multiplying this x by each one of these things. X times x. I'm just going to write these. I'm scoot over because it's going to take some room. So x times x is x squared. X times 2, 2x. And x times the square root of 5 is just x square root of 5. Then I'm going to move to that middle term, this 2 right here, and I've got to take that 2 and multiply it by each one of these things over here. So 2 times x, 2x. 2 times 2, I'm going to go ahead and say that that's 4. And then the last one would be 2 times the square root of 5. So 2 square root of 5. Everybody okay with that? So I multiplied the x by everything. I multiplied the 2 by everything on the other side. And I need to multiply this negative square root of 5 by everything. So negative square root of 5 times x would be negative x times square root of 5. Negative square root of 5 times 2. That's going to be minus 2 square root of 5. Negative square root of 5 times square root of 5. I'm hoping we can cheat here, because we did that introduction about how we talked about the square root of 5 times the square root of 5 is what? 5. Okay, negative square root of 5 times the square root of 5 is just 5. Okay, is any of this stuff going to collapse out? I still haven't, let's see. I don't see any more x squareds, so I still have an x squared. 2x, and I've got another 2x, so I took care of that. 2x and 2x, that's going to be 4x. Okay, I've got, oh, this is good. Negative, or I've got a positive x squared of 5 and a negative x squared of 5. That makes us happy because that's 0. I've got a positive 2 square root of 5 and a negative 2 square root of 5. And I can combine the plus 4 and the minus 5 to get negative 1. So, deep breath. Okay. We're almost done. Now, that was the difficult part. That one, multiplying all that, was difficult. This part, because we don't have any i's or any square roots left, this is pretty straightforward. So we're taking our x squared and we're multiplying it by both the things over here. So x squared times x squared, that's going to be x to the 4th. X squared times 4, 4x squared. Moving to the next term, which is the 4x, it has to get multiplied by both of these things. So 4x times x squared would be plus 4x to the 3rd, and 4x times 4 would be plus 16x. Then our last negative 1, it still has to be multiplied by both of these things over here. So negative 1 times x squared is negative 1x squared. Negative 1 times 4 is negative 4. So we want to see if for our final answer, can we combine anything? I've got an x to the 4th, and I don't see any other x to the 4th, so that's there. 4x to the 3rd. I don't see any other x to the 3rds that can go with that. I do have a 4x squared minus 1x squared, so I just have 3x squareds because I've got 4, take away 1, and then 16x minus 4. Okay, so I would imagine that on your homework, there's only probably one that is that difficult. That one was difficult because it had those 2 that we had to subtract that had square roots and i's in them. But I want to make sure that I at least work one that's complicated like that for you. Example 4, way easier. Okay. Example 4 is way easier. Any questions about example 3? So I think that for today, we will probably just do example 4 and we will not do example 5 because it's complicated. We'll save that for, because 8.4 is not due until next Sunday. And I don't want to rush through example 5. So we will probably do that on Monday. But you'll for sure be able to do 8.4 support, and you'll be able to do several problems in 8.4 if you want to go ahead and get started on that. So for example, 4 says, for the polynomial with the given roots, find the remaining zeros. It's telling me that these are zeros. Okay, so if those are zeros, here's what you need to think about. They will go into this polynomial evenly with a remainder of 0. If they are zeros, then they have a remainder of 0. So what we want to do is we want to use what we know from 8.3 about synthetic division, and we want to divide these zeros out so that we can get something smaller than this to factor. Okay, so remember that when you were doing synthetic division, you would say, I'm going to start with 3 here. I actually have 2 zeros here. I have a positive 3 and a negative 3. I'm just choosing to start with the positive 3. And then you would write your coefficient. So we've got 1x to the 4th. How many x to the 3rds do we have? You have to put 0 to hold that spot. So we have 1x to the 4th, 0x to the 3rds, 27x squareds. We don't have any x's to the first power, so we would put a 0 there, and then we would say minus 324 at the end. What if this works right? Since it is a 0, when I do synthetic division, this answer should be 0. Okay, so I'm gonna bring down the 1. 1 times 3 is 3. That goes right here. You add these, 0 and 3 is 3. Multiply the 3 times the 3, put this right here, get 9. Add these, 27 and 9, 36. Okay, you multiply the 36 times the 3. You put the answer right here. 36 times 3, 108. You add these, 0 and 108 is 108. Take the 108, you multiply it by 3, and you get 324. Negative 324 and positive 324, 0. Okay, so what did that tell me? What it told me is that now I have a new equation because I factored 3 out. My new, since this was an x to the 4th, what is the answer going to be? Remember, it's always 1 less. So if this is x to the 4th, this one's going to start out as x to the 3rd plus 3x squared plus 36x plus 108. So that's what I know now. I got it down a little bit smaller. At least we don't have an x to the 4th. We just have an x to the 3rd. So then you want to take that, same coefficients, 1, 3. I'm just taking my answer that I had before. These numbers that we just had. And I know that my remainder is supposed to be 0 because I've got one more thing that I can make this a little bit smaller if I divide out what? -3. I already did +3. They told me that -3 was also an option. I could have done that first if I had wanted to, and it would have been fine. So I'm going to bring down the 1. 1 times -3. -3. Add these, you're going to get 0. 0 times -3 is 0. Going to bring down the 36 because 36 and 0 is 36. 36 times -3, -108. 108, -108 is 0. So my coefficients now. So I started with an x to the 3rd this time, right? So now I'm down to what's next. So this would be, yeah, absolutely. This would be 1x squared because it's always 1 less than what we had, plus 0x, which we don't really need to write, but I'm just trying to explain, plus 36 is equal to 0. Right? Which just means x squared plus 36 is equal to 0. So we started out with something that had an x to the 4th. So it's possible that this thing has 4 zeros. 2 of the zeros are +3 and -3. My job is to find the rest of the zeros. That's what the whole problem is. So this is quadratic. How do you find zeros with quadratic? If I said, tell me the x-intercepts are the z, let's forget about the rest of this problem. And this is your problem. Find the zeros for x squared plus 36. What are you going to do? If you're going to solve it by hand, yes. You go to the quad program and you type in A is 1, B is 0, C is 36. Enter tells you the answer, right? Okay. But I wouldn't be a good math teacher if I didn't do the rest of this problem. So x squared equals -36, right? To get rid of a square root, you have to, to get rid of a squared, you have to take the square root. Well, this square root I can divide into the square root of -1 times the square root of 36. So the square root of -1 is what? Dealing with square roots, so we're going to have a plus or minus. I, square root of -1 is I, and this would be 6. So plus or minus 6i would be my final answer. So my other two zeros are 6i and -6i. Which the quad program would give you those if you hit enter twice, right? Okay. So Monday, we're going to start with example 5. We'll probably also cover 5.1. 5.1 is a really short section. So, but we're doing good.